Good evening, everyone. This is a brand new day, a brand new week. Today is Monday, right? A brand new day, brand new week, and a brand new topic, which is refraction. The last class, we were supposed to start with refraction, but we were busy in doing that problem on that mirror, and I remember that I did a few stupid mistakes in that. Anyways, I'll try not to repeat the same mistakes in this class. I'll look for some new mistakes. Refraction is the next heading of our chapter. And before going any further, I would like to ask you, what do you mean by refraction? And I hope that you know the definition of refraction. What do you mean by refraction? Anyone? And why does refraction happen? What do you mean by refraction and why does refraction happen? Yes?
Sir, bending of light ray when it passes from one medium to another medium.
Well done. Who is saying, from which class? I can't see anyone.
Sir, Abhiram, sir.
Oh, yeah, that's why I can't see. I'm looking at the class.
Online, sir.
Okay, I'm looking at the class and I hear voices coming out of the class just like Akashvani, and I can't see anyone speaking, and that was fabulous. Yes, it is the bending of light rays when it moves from one medium to the other medium. Why does light bend? Is the next question. Why does light bend? Yes, Abhiram or anyone. Why does light bend? Don't chit chat in the class. Why does light bend if it bends?
Because the medium changes.
So because of medium changing, what happens is my question, my dear friend. What happens when medium changes? What happens? Why does light bend? Why it bends? Because medium changes. Yes, I got it.
Refractive index changes.
Refractive index changes. What is refractive index? Yes, you're coming there. What is refractive index? See, you can't say something that we have not defined. We have not defined refractive index yet. So if you are trying to understand refraction in terms of refractive index, we'll first have to define refractive index. We have not defined it. So I cannot make you understand refraction by refractive index. I'll have to use something else. Why does light bend is the question again.
Sir, like the velocity decreases when it passes through the second medium.
Is it necessary that the velocity should decrease? It can increase as well, no?
Yes, sir.
So what happens is, if I have this, and what is this? This is not a line, this is boundary between two mediums. And I have drawn this boundary before as well. This is boundary between two mediums. Okay, so on this side we have medium number 1 and on this side we have medium number 2. Now the best example could be the surface of lake. On the top side we have air or atmosphere, and below the lake we have water. So one medium, other medium. Now what happens is, if light strikes a boundary between two medium, and my light is not going anywhere, not going good, this is better. When light strikes, this is the incident ray, it is striking the boundary between two mediums. So what all things can happen here? The first thing that can happen here is that it will go back in the same medium. Yes or no?
Yes, sir.
Yeah, so that phenomena is known as what is that known as? It goes back in the same medium.
Reflection.
Reflection. We have already dealt with reflection. Let me just go back. This is angle of incidence I. This is angle of refraction R. So far, so angle of reflection R. This phenomena is known as reflection. But it will also happen that instead of getting bounced back in the same medium, light can also pass into the second medium. This phenomena, when light passes from first medium to the second medium, and in doing so, it gets bent. It bends. Now, what do you mean by it bends? Now, this is the original light ray. Do you see this original light ray? Going like this. Now, as you can see, this is the original path which I have drawn. This is the original path. This is the original path. This is my normal. Do you see my normal? Normal is your perpendicular drawn. Now, this is the original path. Now, sometimes, oops, my pen is gone. Sometimes it can bend here like this. We call this bending towards the normal. This is bending towards the normal, or it can go like this. And this will be known as bending away from the normal. So, whenever light enters from one medium to the other medium, it does not go straight. It cannot go straight. It will bend. Either it will bend towards the normal or it will bend away from the normal. This phenomena of light, where it moves from one medium to the other medium and it bends, the bending of light rays, when it travels from one medium to the other medium, is known as refraction. Do we understand this? We can
Yes,
also
sir.
call it transmission.
Yes, sir. Sir,
can
am I audible?
Yes, you are audible and your voice is sounding very sweet as well. Okay, where was I? Okay, I forgot what was saying. Okay, it may bend towards the normal, it may bend away from the normal. When it is going to do what? We will see that. Don't worry. This phenomena is known as refraction of light. It may be also called as transmission, because we will be using this term transmission, maybe not in this chapter, but maybe in the chapter on thermodynamics. We have done thermodynamics, yes or no?
Yes, sir.
Yes, sir. So, if I just relate this thing with thermodynamics, how does it look like? Just see. See, thermodynamics is a study of heat waves or heat rays, radiation. Now, light is also a radiation, so I can relate this with thermodynamics as well. Now, imagine, then this will just give you a feel of how things are related. Imagine this is a surface. Do you see this is a surface? Now, when radiation, let us see, this is radiation. When radiation, let us say Q, when radiation Q falls on this surface, what all things can happen? When some radiations, Q, heat, light, electromagnetic wave, ultraviolet wave, any ray, it falls on a surface, what can happen? Some part of it can be reflected back, yes or no? Some
Yes,
part is
sir.
reflected back,
Yes, sir.
we call it QR. Some is reflected back. Some part of it may be absorbed, yes or no?
Yes, sir.
We call it QA. Some part of it may be absorbed and the other part may get transmitted. Do we understand this? So there are only three things that can happen when radiation falls on a body. Either it can be reflected back, or it can be absorbed, or it can move through. This moving through is known as transmission. Do we understand this?
Yes, sir.
And this transmission is same as this reflection, yes or no? This transmission is same as this refraction, yes or no? So we can also call it transmission if you want to. Transmission or refraction, they refer to the same thing. So instead of, sometimes what happens is we get confused between this R, because this R is also used for reflection and this R is also used for refraction. Now we may get confused by this. I get confused if R is used, whether it is used for reflection or it is used for refraction. So normally what do? I call it T. Do you understand why I'm calling it T? T is standing for transmission. If this T looks bad to you, you can also use R. But here R will mean refraction rather than angle of reflection. Do we understand this?
Yes, sir.
So here what all things we know? This is our incident ray. This is our reflected ray. We have already dealt with reflection. And this red one is bending towards the normal. This blue one is bending away from the normal. This is my refracted ray. This phenomena of bending of light rays when it travels from one medium to the other medium is known as refraction. Now the point is, why does refraction happen? Why does refraction happen? When light moves from one medium to other medium, what all things change and what all things remain same? When light travels from one medium to the other medium, what all things change? What all things remain same? Yes. Any idea? Note it down. When light travels or any wave travels from one medium to the other medium, what all things change and what all things remain same? I hope you can see this. Yes or no? So when light travels from one medium to other medium, f, which is the frequency of light, this remains same, because this frequency is determined by the source of light. Right now the source of light, I think, is my LED bulb. The frequency depends what frequency it is emitting light. It depends on this bulb, does not depend on anything else. So frequency remains same, but something changes. What changes? V and lambda. What is V? What is lambda?
Velocity and wavelength.
V is the speed of light and lambda is the wavelength of light. This changes. And remember this formula, V is equal to F lambda. V is equal to F lambda. This formula remains valid. Now frequency F will remain same. So therefore V and lambda must change. If V increases, lambda also increases. If V decreases, lambda also decreases. Speed of light is not same in all the mediums. Speed of any wave is not same in all the mediums. In some medium it is fast. In some medium speed is less. In which medium is the speed of light fastest? In which medium is the speed of light fastest?
Rarer.
Gaseous medium.
In which medium is the speed of light fastest?
So vacuum.
Yes, well done. The speed of light or any electromagnetic wave is fastest in vacuum. It's fastest in vacuum, and we call it speed of light is fastest in vacuum, and we call it c, which is 3 into 10 raised to the power 8 meter per second. Do we understand this? Speed of light is fastest in vacuum, and we call it c, 3 into 10 raised to the power 8 meter per second. So far so good? Okay, now in any other medium, the speed of the light will be slower than this. Do we understand this? Now, here comes the two terms that we must understand. And the two terms that we must understand are number one, A rarer medium, B, denser medium. What do you mean by a rarer medium and what do you mean by a denser medium? Yes. If you understand these simple things, life is going to be great. Yes. What do you mean by a rarer medium? What do you mean by a denser medium? The meaning is hidden in the term itself. Denser, dense. If it is dense.
So
Dense
the denser
means-
yeah,
Yes.
please continue.
Say.
Denser means in depth, deep.
Okay. Here, bachcho, we are looking at the speed of light. We are trying to understand the speed of light, and in that reference, we are looking at rarer and denser medium. So a rarer medium is a medium in which, yes, Abhiram, you were saying something?
So the denser medium will reduce the speed of light while the rarer will increase. With respect to if it's traveling from a denser medium to rarer medium, it will increase the speed.
Medium does not increase the speed. Okay, you are not saying it in the correct way. Rarer medium, I'll just correct what you are want to say. Rarer medium is a medium in which speed of light is more. Speed of light is more. When we compare two mediums, we will call the medium in which the speed of light is more as rarer medium. Then what will you call the denser medium? Speed of light is less.
Less.
Here we are comparing two mediums. Now, which is the rarest of medium? Vacuum. Vacuum is rarest of all medium. Why it is rarest of all medium?
Speed of light is fastest in
As yes, my dear friend, that is correct. Speed of light is fastest. Speed of light is fastest in vacuum, and therefore vacuum becomes my rarest medium. Can I have raised hands from everyone that we are getting this? It's not going above our heads. Well done. Backbenches? Yes. Okay. Now, rarer medium, denser medium. Vacuum is the rarest of all medium. Now, to understand how rarer or how denser a medium is, we have devised a term, and that term is known as
Can you repeat the question again, sir?
refractive index.
yes, the answer is refractive index. And the question was, how do we know which medium is rarer and how do we know which medium is denser? To find out that, we have devised a term which is known as refractive index. So that is the next heading that we are going to write. Refractive index. Refractive index normally denoted by the letter mu. Refractive index denoted by the letter mu. Now what is this refractive index? It tells us what? It tells us whether a medium is rarer or whether a medium is dense. Refractive index. Now, remember, whenever we make a unit, there must be some reference. 1 meter, you must know how much is 1 meter. Then only we can find out what is the length of other thing. Now, to have this refractive index, we must have some comparison that we can have. So what we have done, we have called the refractive index of vacuum as 1. Do we know this? Refractive index of vacuum is taken as 1. Refractive index of vacuum is 1. Now, if the refractive index of vacuum is taken as 1, how do you find the refractive index of any medium with respect to vacuum? So this is how you write it. I'll just write it in a different, better. Mu is refractive index. Medium with respect to vacuum is equal to C divided by Vm. Oops, what is this? I don't like this. C divided by Vm. You can write it as Vm or you can simply write it as V. What does C stand for here?
Speed of the light.
Speed of light in where?
Vacuum.
Speed of light in vacuum. What does Vm or V stand for? This stands for the speed of light in vacuum, and this stands for speed of light in air. Do we understand this?
Yes, sir.
So this is how you can find out the refractive index of any medium. Refractive index of any medium. For example, speed of light in glass is 2 into 10 raised to the power 8 meter per second. Find mu of glass with respect to V. Now, remember, whenever we find the refractive index of any medium with respect to vacuum, refractive index of any medium with respect to vacuum, this term is sometimes known as absolute refractive index. When I say absolute refractive index, it means refractive index with respect to air or vacuum. Is it getting too complicated? Or are we able to understand this? Can I have some raise hand that we are able to understand this? Everyone? Okay. Remember, these are very simple things, beta. If you can just remember these simple things, I hope that you will be able to understand. So whenever I am finding out refractive index of any body, any medium with respect to vacuum, I call it absolute refractive index. Can you find out the absolute refractive index of glass with respect to vacuum, obviously? How will you find it out? Yes, my dear friends.
So 3/2.
3/2, that is correct. What about the others in the class? Do we get this? This is a yes, and this unfortunately is a no. Yes or no? So how do you find the refractive index of glass? Mu of glass with respect to vacuum or air. You simply divide the speed of light in vacuum, 3 into 10 raised to the power 8, by the speed of light in that medium, and you get this number. Remember, refractive index is a number. It does not have any unit. Do we understand this? It is a pure number. It is a ratio. It does not have any unit. Do we understand this?
Yes, sir.
Anyone got this answer?
Yes, sir.
This is known as absolute refractive index. It is going to tell us how fast or how slow light is. Light is fastest in vacuum. It cannot be faster than this. So, refractive index or absolute refractive index of any medium, an important point. Absolute refractive index of any medium with respect to a vacuum will always be greater than 1. Do we understand this? Important point. Might
Yes,
come
sir.
as a straightforward knowledge based question in your NEET. Refractive index of any medium, absolute refractive index of any medium with respect to vacuum will be greater than 1, and the refractive index of vacuum is, my dear friend, 1. Do we understand this? This was absolute refractive index. This is refractive index of medium with respect to air. But we can also find the refractive index of one medium with respect to the other medium. Refractive index of one medium with respect to the other medium. That in some cases is also known as relative refractive index. It is also known as relative refractive index. So you can write it as next heading, and you can write it star 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 relative refractive index. This relative refractive index or relative mu is nothing but refractive index of one medium with respect to the other medium. Refractive index of one medium with respect to the other medium. And how I'm going to write it? Mu 2 with respect to 1. Mu 2 with respect to 1. Refractive index of the second medium with respect to the first medium. Refractive index of the second medium with respect to the first medium. Do we get this? And you can find it out by dividing the refractive index of the second medium with respect to vacuum by refractive index of the first medium with respect to vacuum. Now remember, instead of writing vacuum always, it just becomes too clumsy. So instead of writing this equation like this, you can simply write it as mu2 divided by mu1. I have neglected that V wala sign, vacuum wala sign. Normally it is neglected because everyone knows that refractive index it with respect to vacuum. You don't have to write vacuum, vacuum, vacuum always. Do you understand this? The thing that I have colored in
Yes, sir.
yellow is the actual way of writing it, but we may just avoid V and just write mu2 by mu1. This is known as the refractive index of 2 with respect to 1. This quantity in green, which is same as this quantity or this quantity, this is known as, I'll write it, refractive index Ri of second medium with respect to the first medium. And now we can easily find it out. Mu2 will be C by V2. So you can write it if you want to. C by V2 divided by C by V1. So you will have this formula, my dear friends, V1 by V2. So I have this revolutionary formula now. This chapter is all about formulae. Mu2 by mu1 is V1 by V2. Do we get this? Yes or no? No or yes? A very important formula
Yes, sir.
appearing right in front of our eyes. Now it might be difficult remembering it this way, but I can write it in a very, very sweet way. And that very, very sweet way is like this. I can write it as mu2 into V2 is equal to mu1 into V1. Do we understand what I have done here, my dear friends? This is the simplest way of remembering this. I remember it this way. Mu2 into V2 is mu1 into V1. Or I can write it as or mu into V is a constant. Yes or no? No, yes.
Yes, sir.
Yes, sir.
Mu multiplied by V is a constant. If V is more, mu is less. If V is less, mu is more. Okay? Now,
Yes, sir.
now, now we can understand. Mu into V is a constant. That means if that means if that means if V is more, mu is less. Okay? Will you remember this?
Yes, sir.
Then we can now move and I will just show you a simple table which is all about absolute and relative refractive index. This is just shown in the form of a table. I'll just show you this table. And this, if you want to write anything, you can write, else we have written everything that was possible in this table. This is just to show the difference between relative and absolute refractive index. Absolute refractive index or refractive index of any medium will be C divided by V. Do we understand this? And here they have calculated the refractive index of glass with respect to air, diamond with respect to air, and crown with respect to air. You don't need to write this, you just have to see it. Then it is relative refractive index. When we are comparing the refractive index of two medium with respect to each other, this is the term that we have seen. Mu of 2 with respect to 1 is mu 2 by mu 1, which is V1 by V2. Do we remember this? Yes or no? No, yes?
Yes, sir.
Okay. This is all about refractive index. Now, we have seen that when light will travel from one medium to other, mu will change, V will change. It goes from rarer to denser, what will happen? If it goes from denser to rarer, what will happen? We will also see this. Okay. Now, you can just note down one more formula from here. And remember, it's all about formulae in this chapter. So I'll just give you one more, which is relating your mu with one more thing. So I'll just give you that formula and I hope you will understand this. Mu 2 by mu 1 is equal to V1 by V2. We have seen this, yes or no? Now V is equal to F lambda and F remains same. So this will be equal to lambda 1 by lambda 2. So this is one more way in which you can remember this. We have seen that mu into V is a constant, my dear friends. Mu into V is constant. So you can also remember this. Mu into V is a constant. Similarly, so they are not same. They are not the same constant. So I cannot equate it here. Mu into V is a constant. At the same time, mu into lambda will be a constant as well. Do we understand this? So when light travels from one medium to other medium, if the refractive index increases, wavelength will decrease. Do we understand this?
Yes, sir.
Yes, sir.
Please remember this, because these are all the terms that are going to come in an examination hall, and straightforward questions will come from here. So you will have to note down all these terms. One more term which I am going to show you.
Sir, can you please wait?
Yes, I'm waiting, don't worry. You tell me, you don't have to write the entire thing in the table. Do you understand this better? If we have already discussed this, you don't have to write the table. Do you understand this?
Yes, sir.
Table is just for you to see, nothing else. We have already written everything from the table, what we require. The only thing you need to write is mu into v is constant. Similarly, mu into lambda is constant. And one more thing will come. So just. If you can remember these 3 or 4 terms, the refraction is already over. You don't have to write the table better. Do you understand this?
Yes,
I've already
sir.
written this. You just have to write the formula that I've given. Mu into v is constant, mu into lambda is constant, nothing else. Shall I move ahead?
Yes, sir.
Okay. One more thing that
Sir,
is.
sir, just a minute, sir.
What are you writing? So much was there to write. Can't see. Okay. Take your time.
Completed, sir.
Completed.
Yes, sir.
Then this is what you will write, and this is important. Not the Cauchy's equation. It is not in your course. Cauchy's equation is not in your course. But what is in your course is that you understand, and have not encircled this correctly. Now remember, do you know white light is a combination of 7 different colors? Yes or no? No or yes?
Yes, sir.
7 different colors.
Yes, sir.
The wavelength of violet is the least. Do you know this? Vibgyor,
Yes, sir.
Vibgyor.
Yes, sir.
Wavelength of violet is lowest, and wavelength of red is the highest. Yes or no?
Yes,
Yes,
sir.
sir.
Now, you have seen rainbows, right? Why do rainbows happen? Remember, the refractive index of glass or any medium, it also depends on the wavelength. Do you see here? This is refractive index, and these are wavelengths here. Do you see this? Refractive index
Yes,
for
sir.
any medium material depends on the wavelength of light that is falling on it, my dear friends. So if different lights, different wavelengths fall onto it, mu will be different. And therefore, in case of rainbow, in case of white light, violet has the lowest wavelength, and therefore mu for violet is the highest, but mu for red is the lowest. Do we understand this? You will have to remember this fact. So it is
Yes, sir.
inverse. It is inverse. You will have to remember this. Inverse, 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 inverse. Do we understand this?
Yes,
Yes,
sir.
sir.
Cauchy's equation, you don't have to remember. Just have to relation. You just have to remember the relation that I have boxed in the blue box. That is what you got to remember. Not the Cauchy's equation. Cauchy's equation is the explanation of why it is happening. You don't have to remember that. You just have to remember the blue box. Blue box is what is important for you. Noted it down, bacha?
Yes, sir.
Then comes same thing, written more point wise. On what all factors refractive index of a medium or glass depends on? Question has come many time in NEET. It's an information based question and you will have to note down as it is. On what all factors does the refractive index of a medium depends on? It depends on the nature of medium, obviously. If it is air, refractive index is different. If it is glass, refractive index is different. If it is water, refractive index is different. Yes or no?
Yes, sir.
The second point is the most important point. Color of light or the wavelength of light. You have just seen that. Yes or no?
Yes, sir.
Cauchy's equation. Inversely proportional to the wavelength of light. More the wavelength, less is the refractive index. Don't forget this. Third, which we might skip, is the temperature of the medium. Refractive index decreases with increase in temperature, so it is inversely proportional to the temperature. You can write it in short. Refractive index is inversely proportional to I should not write r, I should write mu. Sorry for that. I should write mu. Refractive index is inversely proportional to wavelength. Refractive index is inversely proportional to temperature. Do you understand this?
Yes, sir.
Yes, sir.
Shall we move on ahead?
Yes, sir.
Comes this very important fact. Mu of 2 with respect to 1 is mu 2 by mu 1. Mu of 1 with respect to 2 will be mu 1 by mu 2. So they are the inverse of each other. Yes or no? Refractive index of 2 with respect to 1 will be the ulta of inverse of refractive index of 1 with respect to 2. Yes or no?
Yes, sir.
Do we all understand this? Raise hand will give me more confidence that the refractive index of 1 with respect to 2 will be the inverse of refractive index of 2 with respect to 1. From here, we can understand this very nice principle which is coming to you in this red block, which is known as the principle of reversibility of light ray. Have you seen this principle of reversibility of light rays? In fact, we have used it in reflection. Yes or no? I told you if a ray of light is parallel, after reflection it will go through the focus. If I reverse the ray, if it passes through the focus, it will go parallel to the principal axis. Yes or no?
Yes, sir.
Yes, sir.
That was principle of reversibility of light. If this is the incident ray and this is the reflected ray, if I reverse, if I make this one as the incident ray, this one becomes the reflected ray. Yes or no?
Yes, sir.
Yes, sir.
Similarly, please see. In this case, this is the incident ray. Do you see this?
Yes, sir.
Incident ray is in medium number 1. Do you see this?
Yes, sir.
And my gentlemen, this is the reflected ray, green ray. Do you see this? No, not reflected, it is refracted. Why I'm writing reflected? This is the refracted ray, you see? This is the refracted ray.
Yes, sir.
Yes,
It is
sir.
it is in the second medium. So incident ray is ray 1 in medium 1. Refracted ray is ray 2 in medium 2. Red is the incident, green is the refracted. If I reverse it, that means if I make this as the incident ray, then what would be my refracted ray, my dear? This one in the ulta direction would be my refracted ray. Do we understand this?
Yes, sir.
Yes,
Only
sir.
the direction of arrow will change. In first case, the direction of arrow is like this. In second case, direction of arrow will be like this. Do we understand this?
Yes, sir.
I shall draw
Yes,
the
sir.
arrow ka direction. See, this is the arrow ka direction. In the second case, this is known as the principle of reversibility. And my dear friend, it comes from this simple result that we have written here. Refractive index of 1 with respect to 2 is equal to inverse of refractive index of 2 with respect to 1. Do we get this? Yes or no?
Yes, sir.
Yes, sir.
Let us look at point number 2. You don't have to draw this. If you want to draw this, you can draw this. You are welcome, but this you just have to write the reversibility principle. I have to show you this. So I have done this. Now remember the second principle. Now, refractive index of 2 with respect to 1 multiplied by refractive index of 3 with respect to 2 multiplied by refractive index of 1 with respect to 3. If I keep on doing this, what will I get? So just see, refractive index of 2 with respect to 1 will be mu2 by mu1. Refractive index of 3 with respect to 2 is all getting multiplied, will be mu3 divided by mu1. Refractive index of 3 with respect to 1, everything is getting multiplied, my dear friends. Mu1 by mu3, and at the end, everything will get cancelled out. Yes or no, my dear friends?
Yes, sir.
Oh, I have written it wrongly. This is 2. Everything will get cancelled out. Yes or no? Tongue, 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 tongue. I will get
Yes,
1.
sir.
That means, now how do I see it? That means if I have a ray, which is incident ray in medium number 1, incident ray in medium number 1, then my dear friends, it goes to medium number 2, refracted. Then my dear friend, it goes to medium number 3, again refracted. Then my dear friend, it comes back to medium number 1 on the other side. Now this ray that you get and this ray that you get will be parallel to each other. Do we understand this? Both the rays would be parallel. So this ray, if I call this as ray number 1, this is also, if I call this ray number 4, which is coming out, and here we have parallel slabs. These slabs are known as parallel slabs. Ray number 1, which is incident, and ray number 4, which is emergent, they will be parallel to each other because ray is incident in first medium and ray is coming back into the first medium. If that happens, the ray will always remain parallel. We will see it in a topic known as lateral shift, which we are going to do just after this. Apparent depth, real depth. Here we will do this. I just wanted you to remember this formula that I am putting in a box. Do you understand this? That this will
Yes,
be
sir.
equal to 1. This equal
Yes,
to
sir.
1. This equal to 1 means that, means what? Means that the ray will be coming out like this. So this is the meaning of this equal to 1. Do we understand this? And that is why I have shown you this. Yes or no? No, yes?
Yes,
Yes,
sir.
sir.
That is refraction, and we have understood at least the meaning of refractive index. Can anyone tell me what do you mean by refractive index? What do you mean by absolute refractive index? What do you mean by relative refractive index? What does refractive index tell us? What do you mean by rarer medium? What do you mean by denser medium? Who is going to tell me all of this? Say. I'm waiting.
Sir,
No. Yes.
when light changes its medium,
Okay. When it goes from one medium to other medium. Yes. Yes. Say.
towards normal or away from the normal,
This
it is
phenomenon.
called refractive index.
It is called refraction.
Refraction.
Why does this refraction happen? Why does it?
When light travels from one medium to another medium.
The speed of light changes and therefore it bends. The medium in which speed of light is more is known as rarer medium. The medium in which speed of light is less is known
It
as.
is called denser medium.
What is the rarest of all medium?
Vacuum.
Vacuum or air, almost similar. The speed of light is almost similar. The refractive index of that thing is taken as 1.
One.
In any other medium, the speed of light will be less, and therefore the refractive index will always be greater than
1.
1. How to find out the absolute refractive index? Speed of light in air or vacuum divided by speed of light in the medium. How do you
Medium.
find the absolute refractive? That is how you find absolute refractive index. How do we find relative refractive index? Mu2 by mu1 is v1 by v2, or mu2 into v2 is equal to mu1 into v1, or mu into v is a constant. Do we remember this?
Yes, sir.
Yes, sir.
Now, quickly, before winding of this class, we can quickly move on to what? Laws of refraction. And everyone knows this laws of refraction. Yes or no? No, yes.
Refraction, sir.
Yes, laws of refraction. Tell me
Yes,
fast.
sir.
What is the first law? Fast.
Sir,
Yes, sir.
the incident ray and
The incident ray, the refracted ray, and the normal lies on the same plane.
Incident ray, refracted ray, and normal lie in the same plane. Do we understand this? Yes or no? Can I have raised hand from everyone that we know this? Second law.
Snell's law.
Second law is known as Snell's law. Tell me, fatafat, what is Snell's law? Don't be scared.
so sin I and sin R is equal sin I divided by sin R is equal to constant.
Sin I divided by sin R is equal to constant. And what is that constant equal to, my dear friend? So here we have, as you can see, we have an incident ray.
Constant.
Do we see an incident ray, bacha?
Yes, sir.
Do we see a refracted ray, bacha?
Yes, sir.
Incident ray, my dear friend, is in medium number 1, whose refractive index is mu1 or n1. Here it is given as n1. You can write it as mu1. And the second medium has a refractive index of mu2. Do we understand this?
Yes,
Yes,
sir.
sir.
Snell's law, as Abhiram rightly said, sin I by sin R is a constant. And what is that constant equal to, my dear friend? It is equal to mu2 or n2 divided by mu1 or n1. Do we understand this?
Yes, sir.
Now I am going to write everything together, my dear friends. You all know this. Let us write this fast. Sin I by sin R. Don't forget this. Is mu2 by mu1, Snell's law. Mu2 by mu1 is v2 by v1. No. It is v1 by v2. And that is equal to lambda 1 by
Lambda
lambda
1 by
2.
lambda 2.
Everyone remembers this?
Yes, sir.
Everything written together. That's why I had to do it together. That's why I had to do it before the end of this class. Now these three we have written like this. Mu into v is constant. Mu into lambda is constant. Yes or no?
Yes, sir.
Yes, sir.
Can I write the similar thing here? Now see. That's the beauty of physics. I can write from this green thing. This is green and this is also green. Taking these two greens together, I can also write it as mu2 into sine of r is equal to mu1 into sine of I. Yes or no, my dear friends?
Yes, sir.
Yes, sir.
At least it's not looking so good. Not looking so good here. Sine I and sine I are always confused which is I, which is R. Right? Now, do you remember that principle of reversibility? है ना? Reversibility? Remember that? Yes or no?
Yes, sir.
Say, if this is my incident ray, dung 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 dung, then this is my refracted ray, dung 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 dung. Yes or no?
Yes, sir.
If I reverse it, my dear friends, this is my incident ray, dung 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 dung, and that will be my refracted ray. Yes or no?
Yes, sir.
Now, instead of calling one angle as I and R, because I and R depends on which is the first medium and which is the second medium. Yes or no?
Yes, sir.
I can call them like this. Ting, 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 ting. I can call this as I1, angle of incidence in medium 1, and I can call this as I2, angle of incidence in medium 2, because instead of going from 1 to 2, it could have gone from 2 to 1. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
So now I can write it this way. Mu2 into sine of I2 is equal to mu1 into sine of I1. Yes or no? No or yes?
Yes, sir.
Now I have a Krantikari formula, and based on this formula, question came in JEE of this year, and the most difficult question in JEE ever was in 1995 IIT-JEE. It came on this concept, and no one at that point actually knew how it is done. So now I can write this revolutionary equation: mu into sine of I is a constant. Do we understand this, my dear friends?
Yes, sir.
Yes, sir.
So whatever medium is there, you multiply by the sine of angle of incidence in that medium. It can be angle of incidence, it could be angle of refraction, depending on which ray you are taking as incident ray. Do we understand this?
Yes,
Yes,
sir.
sir.
Now I have 4 revolutionary equation. Equation number 1, Snell's law. Equation number 2, this is also a kind of Snell's law. Yes or no? Saying the same thing. Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Can you tell me the third one? That is also Snell's law.
So
Can you
mu multiplied by lambda is equal to
Mu
constant.
lambda equals to constant.
Well done, my dear friends. Now we are talking. Well done. All these are Snell's laws. They are Snell's law, just said in different ways. Everything from here, my dear friend, this one, or 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 this one, they are all equal. They all tell you the same thing. Do we understand this?
Yes, sir.
So,
Yes,
Yes,
sir.
sir.
when you come to the class in the next class, if you forgot or forget even one point of this class, that means the entire class goes down the drain. So I would expect that when you come to the next class, you will go through this class before coming. Can I expect that?
Yes, sir.
We have
Yes,
done a
sir.
lot of hard work in this class. If you understand this, I can tell you a question will come from this much topic only. Comes 45 questions are there. Optics is a major chunk of the topic. Remember this. Everything is just based on the application of this, nothing else. This is the most difficult part. If you understand this, we have done it in a good way. Chalo, I will wind up today's class here. Remember, before coming to the next class, please go through this. Please go through it. That's a humble request. If you have any
Okay,
doubts,
sir.
always come up. To me. I've sent you the sheet of reflection. I probably sent you. I've sent you the sheet of the entire optics. No, yes or no? You got that sheet? That practice sheet?
Yes, sir.
Okay.
Got it, sir.
Okay. So I'll tell you what questions to do in the next class. Right now, you can hardly do any question. So I'll give you the questions in the next class. Take care. God bless you all, beta.
Sir, I haven't received those sheets yet in Telegram.
Beta, I will ask office people to do it. I
Okay,
told
sir.
them they are probably sending it. Okay.
Okay, sir. Thank you, sir.
Take care, beta. Bye bye.